Hello, today I'm going to be solving test 3, problems 1, 2, and 3. So let's start with the first problem. $2,000 is invested at an annual rate of 8% for a period of 5 years. Compute the future values. First, we must know the formula we need to use. So the formula for compound interest is A equals P1 plus R over N to the NT power. However, this is a continuous compound because it's asking for quarterly, monthly, daily, and continuous formulas. So, in that case, the continuous compound formula is A equals P E to the power of RT. So what are we given? We're given that P equals 2,000, R equals 0.08 because of the 8% annual rate, and T equals 5. So let's go to solve the first one, which is quarterly compounding. So in order to solve this, we must plug it into the equation. So A equals 2,000, which is the P, 1 plus 0.08 over 4 times 5. Let's go ahead and solve. We know that 4 times 5 is 20. 0.08 over 4 is 0.02. So we're left with 2,000, 1 plus 0.02 to the 20th power. Hold on, let me get the calculation here. Okay, after computing it in my calculator, the answer is 2,200. So that's our quarterly rate. Now, let's do monthly. For monthly compounding, interest is compounded 12 times a year. So, A equals 2,000, 1 plus 0.08 over 12, and then 12 times 5. Now we're left with 2,000, and then 0.08 over plus 0.08 over 12 to the 60th power. 1 second while I convert this. Okay, after computing it, we're left with 297.9 rounded to the 69. Okay, now let's go to monthly, or not monthly, daily. In daily, this means that N is going to equal 365. So let's go to solve. A equals 2,000, 1 plus 0.08 over 365, and then 365 times 5. This comes down to 2,000, 1 plus 0.08 over 365 to the 1,825 power. Let me go to solve this. This will come out to 298.3.51867. Finally, the continuous compound, which is where the other formula comes in, we're left with A equals 2000 E 0.08 times 5, which comes out to 2983.65. And this is the solution for this problem. Alright, here we are in the second question, number 35. An art gallery offers 50 prints, each is P dollars. Q equals 500 minus 2P prints to be sold. So the first question asks, what limitations are there on the possible range of the price P? So in order to find the limitations, we know that the price P must be a positive number, and it should also ensure that the number of prints sold, Q, is not negative. So the demand function is Q equals 500 minus 2P. For the number of prints sold to be non-negative, we need 500 minus 2P to be greater than or equal to 0. So let's solve for P. 2P is less than or equal to 500. And then divided by 2, so P is less than or equal to 250. So the possible price range is 0 is less than or equal to P, or less than or equal to 250. This is the price range. Now let's go to part B, the elasticity. So in order to find the elasticity, we must first use this formula here. EP equals dQ over dP times P over Q. So we need to first find the dQ over the dP. And from the demand function, we have Q equals 500 minus 2P. So we have dQ over dP equals -2. So the elasticity of the demand is -2 times P. Hold on, let me put a dot here instead. Times P over 500 minus 2P. So the elastic demand occurs when EP is greater than 1. The inelastic occurs when EP is less than 1. And the unit elastic occurs when P is equal to 1. So now we're on to part C, interpreting the results. It'll be easier if I just read from part B. So in this case, okay, sorry, I clicked the wrong button. So in this case, if EP is less than 1, which is elastic, it means that, hold on, let me make this easier. It means it's the total revenue price times quantity increases as P decreases. For inelastic, the total revenue increases as P increases. And for unit elastic, the total revenue remains constant as P changes. So now let's go to part D. Part D asks, if you were the owner of the gallery, what price would you charge for each print? Explain the reasoning behind your decision. So, in order to find the price that will maximize profits, we must make P, or we're going to solve for P when the elasticity of the demand equals -1. Because this is the price at which total revenue is maximized, and the quantity sold and price are balanced in a way that the further price increases or decrease would lead to a decrease in total revenue. So -2 times P over 500 minus 2P equals -1. If we were to solve for P would equal 125. So this is the unit elastic demand. So setting the price at 125 would maximize total revenue. Alright, last and final problem. Find the area under the curve y equals 9 minus x squared between x equals 0 and x equals 3. Okay, first let's understand the problem. The curve represents a function, which is a parabola opening downwards. The equation describes how y changes as x changes. So, to find the area, we have to use integration. So a equals 3, 0, 9 minus x squared dx. So now let's compute the integral. The integral of 9 respect to the x is 9x, and the integral of x squared with respect to x is x cubed over 3. So 9 minus x squared dx equals 9x minus x cubed over 3. So now we have to solve for the problem. So let's do it at x equals 3. So 9, 3 minus 3 cubed over 3 equals 18. Let's solve for 0. 9, 0 minus 0 cubed over 3 is going to equal 0. So to find the total area, you subtract these two. So 18 minus 0 is obviously going to equal 18. So the area under the curve y over x equals 9 minus x squared is 18. If the parabola opens downwards, it should look something like this. Hold on. This is 0 and this is 3. Should look something like this. And that is how you solve. Thank you.